Every single semester, a pharmacy student is expected to digest, memorize, and analyze thousands of pages of dense clinical literature. In a standard workflow, just finding the right papers manually drains dozens of hours before the actual analysis even begins. The obvious temptation is to copy a prompt into a general language model and ask it to write the literature review. But in pharmacology, one hallucinated citation can fail a paper or advocate for dangerous drug interactions. This matrix compares our two workflows, the traditional manual approach on the left and the naive AI approach on the right. We evaluate speed and academic trust. The naive AI method wins on speed, but instantly fails our trust requirement. Abandon the search for a single do-it-all tool. A reliable research pipeline requires a segmented stack, where specialized programs manage specific stages of the workflow. Because generating text quickly means nothing if the underlying evidence is fabricated. A segmented approach is the only way to move fast while keeping your facts locked down. This flowchart maps the segmented pharmacy research pipeline. Node 1 is discovery. As detailed in this tool breakdown, Elicit is built specifically to find relevant research papers and save hours of manual searching by directly scraping verified academic databases. The trade-off is its rigid interface. Elicit is a highly focused search engine, meaning it is not designed for broad, open-ended brainstorming. That limitation brings us to Node 2 of the pipeline, ideation and prep. Looking at the ChatGPT section of our list, its strengths lie in providing immediate research explanations and preparing you for a Viva, or oral exam. It excels at dynamic mock testing. However, that conversational fluidity is exactly why it is highly susceptible to factual errors if relied on to generate your actual thesis text. These early phase tools are highly effective at locating and explaining complex medical concepts, but they completely lack the architecture to actually prove those concepts. Once we have our literature, we move to the third node, deep reading and synthesis. For this step, the list points us to Claude. It is optimized for long research papers, allowing it to digest multiple 50-page clinical trials simultaneously to extract core methodologies. But handing an AI a massive document and blindly trusting a one-page summary is dangerous. Claude requires highly specific prompting constraints. If you don't explicitly guide its analytical focus toward things like p-values or exclusion criteria, it will easily overlook crucial statistical caveats buried in the data. An AI's ability to compress hundreds of pages of text is only useful if the human operator knows exactly which clinical nuances to query. Now we hit the critical juncture of the pipeline, Node 4. Validation. This is where Scite steps in. As noted here, its specific function is to show if a scientific claim is actively supported or contradicted by subsequent literature. It does this by mapping smart citations, a metric that visualizes exactly how a specific paper has been referenced by other researchers. The catch is that Scite involves learning this complex, specialized metric system, and accessing its full database typically requires a premium subscription. Finally, we reach the final step, Node 5, polish. As highlighted here, Grammarly is deployed at the very end to ensure a professional tone and syntactical accuracy for the final thesis. It will effectively correct passive voice and comma splices, but it is completely blind to underlying bad science. Polishing a paper that hasn't been rigorously checked against peer-reviewed data is useless. The validation phase is what actually determines your academic success. Let's map daily deployment. The vertical axis measures academic rigor. The horizontal axis tracks daily use. ChatGPT sits bottom right, used constantly for quick explanations, but with low rigor. Scite drops top left, a specialized instrument pulled out for high-stakes fact-checking. If you are early in your pharmacy studies and feeling overwhelmed, deploy Elicit and ChatGPT first. They will immediately reduce the friction of finding papers and grasping basic concepts. But if you're a final-year student optimizing for top marks, your grades depend entirely on uncovering research contradictions faster than your peers. That absolutely requires mastering Scite and Claude. Indeed, the original source material leaves us with a stark reality check. Students using AI will move faster than others. Moving faster is only an advantage if you deploy these tools as a strict verification suite. High-level academic efficiency relies on precise